Hello, beautiful people. Future me. So, oh, I don't have my timing machine. No, 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 no. Reset options. Show this. Minimize that, and improve. Should get all right. All right. That was a quicker one. 4%. Awesome. No, lesson finished. Okay, so where are the other lessons? So, what we will do next? So, C, WebKit, Python, Mercurial, Haskell, Xmonad, Erlang, Objective-C. Okay, I don't know. Come on. path. All right. All right. 9%, still good. 32. Yeah, that's the result. And let's continue. I think I was kind of putting behind the execute program, so we will do execute program. Since I'm paying for it, let's do it. Time to review. Okay, so this one is function length. It gets array of elements of some specified thing and a and returns a number. First one is 2 and is 1. This returns number, but this one is string or number. I think this would work, so it will be 44106. Okay, here we have the same thing, and we try to assign number to string, so this is type error. String or number, yep. So this will return 44106. String or number, return this. This is type error. Yay! Okay, object narrowing. Let's do. We can assign objects to smaller object types. This is called narrowing. We narrow the larger type to smaller type. For example, we might have a full user type. Okay. And Amir email will be Amir at example.com. Sometimes we might not care about the whole user. Maybe sometimes we only care about the email address. That's email. Oh really? That's okay. Amir email. Huh. Huh. It freaking works. Wow. I thought I would have to do more work than just that to get the property. This is cool. This is actually cool. Object narrowing is it called, huh? T. I want T and I will get it. Okay, good. Alright. When we do this, the small type loses knowledge of where it came from. For example, our has email doesn't know about the admin property. Yeah, sure. I'm email type error. Notice that in the example above, we didn't say the user and has email are related. TypeScript knows that they are related because has email is a smaller version of user. User has an email and an admin flag. With email as only email, yeah, understood. This is called structural typing. The object structure determines the type. Some other programming languages would require you to say user is a bigger kind of has email. That would be nominal typing, and it's not supported by TypeScript. Okay, so structural typing and nominal typing, and TypeScript has the structural typing, which it kind of guesses which is smaller. Narrowing can be very useful. For example, our system might have a second send email method. It takes a user, then we have to have a full user to call it. However, a send email that takes email string is more flexible. We can pass it a user. Oh, that's cool. That's cool. I like it. I like it. Oh, it's really cool. I want to use it right away. Hmm. So this allows you use the same function to email addresses that aren't associated with a user object. Yeah, that's just awesome. Here we have some more goodness. Here is example. Okay, so there's a type user string. If you send email, there's the definition of the email in here or the type. Takes email from this and return emailing email. So we have a send email Amer. So this will be emailing uh, mm, this will be oh Amer example.com, and then we have emailing and Betty at example.com. Yay, got it. What was called narrowing? Object narrowing, I think. Let's go. Okay, we are writing we are passing tests. Write a function that returns the name of an object. It should work for any object with the name string property. So we have the narrowing. So we will say name and uh, name string property, and we will return string return name. There we go. That's it. Mission successful. And I don't think I could improve this. This is the best around. Okay, let one literal types. We've seen basic types like number and string. TypeScript has a relatively common feature related to these. Every number and every string is also a type. For example, a variable of type 1 can only hold the number 1. It can't hold 2. That's a compile type error. 1. Okay, so this is 1. Okay, so this is type error. Type error. I'm really surprised that this one you can do this because it basically doesn't do anything. Let one let one this is strange because it would be like let no number the name, and here would be the type definition. It would be inferred, I guess. Love Mati. These are called literal types. For example, the literal. It should be so. Come on. Copy. Pasty. Literal. Okay.
Literal.
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 Literal. Okay. Literal. These are called literal types. For example, the type 1 above is a literal number type. We can combine literal types with unions to allow only certain values. Oh, 1 or 2? 1. Wow. 1 or 2? 2. Wow. 1 or 2? Type error. Why? Why? That is strange. That is strange to me. I never seen it in other programming language. This seems like a strange feature at first. Yes, but it's used often in real-world TypeScript programs. For example, maybe we have a sort function. It can sort in either ascending or descending order. Yeah. So where the direction is either ascending or descending. Descent. This. Help me, Google.
ascending,
ascending,
as ascending,
ascending,
descending, descending,
descending, ascending or descending. Okay, so what is doing? It's getting number, and we have a sortable which we get the this thing sortable sort, and if direction is descending, we reverse or we will return sortable. Okay, sortable sort number. Okay, sort ascending, so it will return 1, 2, 3. Ta-da! Descending, it will return 3, 3, 2, 1. Here we go. Something else. This will be type error. We could theoretically,
theoretically,
what? English.
theoretically,
The
theoretically,
theoretically.
theoretically,
Theoretically.
theoretically,
Theoretically. Theoretically.
theoretically,
Theoretically.
theoretically,
Theoretically. Theor theor the
theoretically,
theoretically.
theoretically,
Theoretically. We could theoretically have used a boolean above, but seeing S, ASC or DESC is more descriptive than true or false. Theoretically. Okay. We have more than 2 possible values. Literal types really shine. For example, suppose that we are writing a database library. Database type MySQL, Postgres, Oracle. Let DB type database type MySQL, so it will be MySQL. Bam. And my success is type error. With this type constraints in place, it's like enum. It's like enum in Java now. That's what it is. And this is strong dancing. What kind of dancing? Xing Reng Xiang dancing. Cool. They don't even have to run the application to see a failure. Okay, user is immediate. With this type constraint in place, a user is immediately told if they try to use our library with an unsupported database. It will also tell them if they have a typo in the database name. They don't even have to run the application to see a failure. It can't run at all because it contains type errors. Thank you. True and false are also literal literal lit, literal literal types.
literal,
Literal. I knew it's literal types. A variable of type true can never be false. Literal.
literal,
literal. Let t true equals to true. True. Type error. This means that we can assign a boolean to a variable of type true. By analogy, we can assign number string to a variable number. Yeah, makes sense. Function b boolean return true. Let t true equals to b t true. What? Because it returns boolean and this is just true, so this is type error. You got me! Got me there. Okay. 4 minutes. Let's see if we can do it in 4 minutes. Oh, tests. Write a function that adds 1, subtracts 1, and does nothing to a does nothing to a number. Argument 1 is number, argument 2 is add, subtract, or leave alone. Okay, so n would be a number. All like option would be add, subtract, or leave alone. We add, subtract, or leave alone. So, and what it will return? Number. So I'm guessing it will return a number. Okay, if O equals and return number plus 1. If O equals subtract return n minus 1 and else return n go. 6 failures. Okay, there is some syntax error. Okay, so how it was like this. Without this? I don't think so. Oh. Go back. And I really forgot this. No, I didn't. Where's the comma missing, huh? Okay, so we'll return n. Run, and we have somewhere. Where's that? What are you missing? Return. Okay. Okay. So That is good. Now we will try do the think at or what about this one? This one works? Okay, so this one looks better. And here there was this, right? Subtract. Expected 5, okay, cool. And here is leave alone. Run it. Okay. Okay. So now if all if all add we'll do something turn n plus 1. This one works. What I was missing before? Subtract. I must have some typo in there before. I don't know what. Never mind. And we are done looking at the time, so and done is better than perfect. Please remember. Bye.